Welcome to our presentation on synchronous versus asynchronous data replication patterns. Today, we will explore the fundamental differences between these two data replication patterns, their unique features, and how to choose the right one for your specific needs. First, we will take a look at synchronous data replication, and then move on to asynchronous data replication. Following that, we will look at the detailed comparison. Next is use cases. And finally, we will look at the factors to consider when choosing your solution. First, we will take a look at the definition. Synchronous replication ensures immediate consistency between source and target data. And how it works is, every write operation is mirrored on the target system before acknowledgement. The diagram illustrates the process of synchronous data replication, where data is transferred and replicated in real time between a source system and a target system. Here's how the process works. Firstly, the source system initiates a data transfer to the target system. Next, the data is replicated in real time to the target system. After the data is received by the target system, it sends an acknowledgement of data receipt back to the source system. Next, the source system waits for the acknowledgement before initiating the next data transfer. Upon receiving the acknowledgement, the source system can proceed with the next data transfer. Finally, this cycle of data transfer, replication, acknowledgement, and waiting repeats continuously, ensuring that data is synchronized between the source and target systems in real time. The key aspect of synchronous data replication is that the source system waits for the acknowledgement from the target system before sending the next data transfer. This ensures that data is consistently replicated and maintained across both systems, providing a high level of data integrity and availability. Synchronous data replication is commonly used in scenarios where data consistency and real-time replication are critical, such as in database systems, financial transactions, or high-availability systems that require redundancy and failover capabilities. Moving on to the benefits of synchronous data replication patterns. First, let's look at strong data consistency. Synchronous replication ensures immediate consistency between the source and target data. Every write operation is mirrored on the target system before acknowledgement, minimizing the risk of data inconsistencies or conflicts. Next, let's look at immediate synchronization. With synchronous replication, changes made on the source system are immediately synchronized with the target system. This ensures that data on the target system is always up to date and reflects the latest changes made on the source. Moving on to the reduced risk of data loss. Since synchronous replication requires confirmation of data synchronization before acknowledging write operations, it reduces the risk of data loss. In the event of a failure on the source system, the data on the target system is guaranteed to be consistent and up to date. And finally, enhanced data integrity. Synchronous replication often involves a two-phase commit process, where write operations are not considered complete until they have been successfully replicated to the target system. This ensures data integrity and reliability, as every write operation is verified before being acknowledged to the application or user. First, we will take a look at the definition. Asynchronous replication introduces a delay between source and target data synchronization. And how it works is, write operations are queued and replicated periodically or on schedule. The diagram illustrates the process of asynchronous data replication, where data is transferred from a source system to a target system without waiting for immediate acknowledgement or confirmation. Here's how the process works. Firstly, the source system sends data asynchronously to the replication service. Next, the replication service receives the data and stores it temporarily for processing. Following that, the data is queued for replication at the replication service. Next, the replication service asynchronously replicates the data to the target system. After the data is stored on the target system, an acknowledgement is sent back to the replication service, confirming the successful replication. Finally, the replication service then confirms the replication back to the source system. The key aspect of asynchronous data replication is that the source system does not wait for an immediate acknowledgement from the target system before sending the next data transfer. Instead, the data is sent to the replication service, which acts as an intermediary, queuing and replicating the data to the target system. This asynchronous approach allows for higher throughput and lower latency in the data transfer process, as the source system is not blocked waiting for confirmations. However, it also introduces the possibility of data inconsistencies or data loss if the replication service or target system fails during the replication process. Asynchronous data replication is commonly used in scenarios where data consistency is important but not critical, such as in data warehousing, log shipping, or backup systems, where the goal is to replicate data efficiently while allowing for some potential data lag or inconsistency. Moving on to the asynchronous data replication benefits. First, let's look at improved performance and scalability. Asynchronous replication introduces a delay between source and target data synchronization, allowing for improved performance and scalability. It reduces the overhead of immediate synchronization, making it suitable for scenarios where low latency and high throughput are essential. Next, let's look at resilience to network latency and failures. Async replication is resilient to network latency and failures since it does not rely on immediate confirmation from the target system for every write operation. Write operations are queued and replicated periodically or based on a predefined schedule, allowing for better tolerance to network disruptions. Moving on to the flexibility in replication timing. Asynchronous replication offers flexibility in replication timing, allowing organizations to prioritize replication based on business needs and workload requirements. It enables them to schedule replication during off-peak hours or adjust replication frequency according to data volume and criticality. And finally, cost-effectiveness. Async replication can be more cost-effective compared to synchronous replication, especially in scenarios where immediate data consistency is not critical. By introducing a delay in replication and decoupling write operations from data synchronization, organizations can optimize resource utilization and reduce infrastructure costs. Alright, let's delve into the technical differences between synchronous and asynchronous data replication. These distinctions are crucial for understanding which approach best suits your specific needs. First off, let's talk about data consistency. Synchronous replication offers strong consistency. This means that the data on the target system is always in sync with the source system in real time. On the other hand, asynchronous replication provides eventual consistency, meaning there might be a delay before data on the target system reflects changes made on the source. Next, let's discuss synchronization speed. With synchronous replication, synchronization is immediate. Every write operation on the source is replicated instantly on the target. Conversely, asynchronous replication introduces a delay, as write operations are queued and replicated periodically or based on a schedule. Now, let's consider the performance impact. Synchronous replication typically incurs higher latency since it waits for confirmation from the target system before acknowledging write operations. On the flip side, asynchronous replication has lower latency, making it suitable for scenarios where immediate synchronization is not critical. Moving on to resilience to network issues. Synchronous replication is sensitive to network latency and failures. Any disruptions in the network can impact the synchronization process. In contrast, asynchronous replication is resilient to network issues, as it doesn't rely on immediate confirmation and can tolerate delays or interruptions in the network. Let's also talk about error handling. With synchronous replication, errors are detected immediately, providing immediate feedback. In asynchronous replication, error handling is deferred, as errors may not be detected until the replication process is executed. Now, let's consider the complexity of implementation. Synchronous replication is typically more complex, often involving a two-phase commit process to ensure data integrity. Asynchronous replication, on the other hand, is simpler in design, making it easier to implement and manage. In terms of scalability, synchronous replication may have limited scalability due to the immediate synchronization requirement, whereas asynchronous replication offers higher scalability due to its asynchronous nature, enabling it to handle larger volumes of data more efficiently. Regarding network bandwidth usage, synchronous replication typically consumes more bandwidth due to constant data transfer, whereas asynchronous replication uses lower bandwidth, as data is transferred periodically or based on a schedule. Lastly, let's touch on data loss risk. Synchronous replication carries a lower risk of data loss since changes are immediately replicated. However, asynchronous replication has a higher risk of data loss due to potential data lag between the source and target systems. Now, let's explore some common use cases where synchronous and asynchronous data replication patterns are applicable. First, let's look at the use cases for synchronous replication. First is financial transactions. In industries like banking and finance, where data accuracy and consistency are paramount, synchronous replication ensures immediate synchronization between transactional databases, maintaining data integrity and reducing the risk of financial discrepancies. Next is real-time systems. Applications that rely on real-time data processing, such as online gaming platforms, stock trading systems, or IoT, Internet of Things, devices, benefit from synchronous replication to ensure that changes are instantly reflected across all distributed systems, providing seamless user experiences and up-to-date information. Now let's look at the use cases for asynchronous replication. First is disaster recovery. Asynchronous replication is ideal for disaster recovery scenarios, where data needs to be replicated to remote backup sites or cloud environments. By decoupling write operations from data synchronization, asynchronous replication offers flexibility and resilience, ensuring that critical data remains available even in the event of a disaster. Next is geographically distributed systems. Organizations with geographically distributed operations, such as multinational corporations or global e-commerce platforms, leverage asynchronous replication to synchronize data across different regions or data centers. This approach allows for efficient data distribution while mitigating the impact of network latency and geographical constraints. As you evaluate your options for data replication, it's essential to consider several key factors to ensure you select the most suitable solution for your specific requirements. Firstly, data consistency requirements should be at the forefront of your decision-making process. Determine whether your application demands strong consistency with immediate synchronization, or if eventual consistency with a slight delay is acceptable. Next, consider performance considerations. Evaluate the impact of latency on your application and whether immediate synchronization is critical. Assess the scalability needs of your system and whether synchronous or asynchronous replication aligns better with your scalability goals. Another crucial factor to consider is network latency and reliability. Understand the network conditions between your source and target systems and determine whether they can support the synchronization requirements of your chosen replication method. Think about the criticality of your application. Are you dealing with mission-critical systems where even the slightest delay or risk of data loss is unacceptable? Or are you replicating data for less critical applications where occasional delays or minor inconsistencies are tolerable? Furthermore, consider the complexity of implementation. Evaluate whether your team has the expertise and resources to manage the complexities of synchronous replication, or if a simpler asynchronous solution would be more feasible. Lastly, cost considerations play a significant role. Assess the infrastructure and operational costs associated with both synchronous and asynchronous replication solutions. Determine which option offers the best balance between cost and functionality for your organization. By carefully weighing these factors, you can make an informed decision that aligns with your business needs, application requirements, and budget constraints, ensuring successful data replication implementation. And with that, we've reached the end of our presentation. We hope you've gained some valuable insights and thank you for your time and attention. If you have any further questions or would like to explore more, please don't hesitate to leave a comment. Please consider subscribing. Every like, subscribe, and share helps this channel thrive, and it truly means a lot.